There's no space. There's no time. There's no darkness, because darkness needs somewhere to exist, and there's nowhere yet. There's nothing. And then, in a moment so brief, it makes the blink of an eye look like a geological era. Everything that has ever existed, everything you've ever touched, everyone you've ever loved, every star you've ever seen on a clear night, all of it detonates into existence from a point smaller than a single proton. Not an explosion into space, an explosion of space itself. Here's what nobody tells you about the Big Bang. It wasn't a bang. There was no sound. Sound needs air. Air needs atoms. Atoms didn't exist yet. What actually happened was so violent, so incomprehensibly dense, that our language, every metaphor we've got, breaks before it can even get close to describing it. But we're going to try, because what happened in the first 3 minutes of this universe didn't just create stars and planets and galaxies. It created the atoms inside your chest right now. And once you understand how it happened, the real sequence, the actual physics, you will never feel the same way standing under a night sky again. Let's establish what we're actually dealing with here. Before the Big Bang, and yeah, before is a word that technically loses all meaning here, but stick with me. All the energy that would eventually become the observable universe was compressed into a state of infinite density. Physicists call it a singularity, a point where the known laws of physics don't break down gracefully. They shatter. Temperature beyond anything calculable. The numbers require scientific notation stacked on scientific notation. Size smaller than anything you can picture. Smaller than a proton, smaller than a quark. We're talking about a scale where quantum mechanics and general relativity, the two most successful theories in the history of science, flat out contradict each other and neither one works. Here's where it gets terrifying. We don't actually know what the singularity was. We can't. Our physics only starts to function at roughly 10 to 43 seconds after the bang, a unit of time called Planck time, the shortest meaningful moment the universe actually allows. Everything before that is a wall, an absolute wall. Scientists didn't just shrug and move on. They tried, for decades, string theory, loop quantum gravity, cyclic cosmology. Brilliant people have thrown their entire careers at this wall, and honestly, it hasn't moved an inch. But what happens after that wall? What happens in the first fraction of a second is where things go from impossible to unimaginably violent. At 10:36 seconds after the Big Bang, something happened that still keeps cosmologists up at night. The universe inflated, not expanded, inflated. And here's the thing, that difference matters more than almost anything else in this story. In a window of time so short it makes an attosecond look like a century, the universe grew by a factor of at least 1026. That's a 1 followed by 26 zeros. Every single point in space was flying away from every other point faster than light. But wait, doesn't Einstein say nothing can travel faster than light? Here's what nobody tells you. That rule applies to things moving through space. This wasn't things moving. This was space itself stretching. The actual fabric of reality expanding so fast that light couldn't keep up with it. Get this. Before inflation, everything in the observable universe, every galaxy, every star, every single atom in your body was in contact. All of it connected, all within reach. Then inflation ripped those connections apart so violently, so fast, that regions of space that were once touching are now separated by distances light will never cross in the remaining lifetime of the universe. The universe is still running from its own beginning. And it's accelerating, but that's not even the terrifying part. The terrifying part is what inflation left behind. The universe is now 1 second old. Temperature, 10 billion degrees. Hot enough that matter and antimatter are being created and annihilated continuously. Particles winking in and out of existence like sparks flying off a grinding wheel. Here's where it gets worse. For every billion antiparticles created in those first seconds, there were 1,000,000,001 regular particles. One extra, a tiny, almost invisible asymmetry baked into the laws of physics. And that asymmetry, that single extra particle per billion, is the only reason the universe didn't annihilate itself completely before anything could exist. Every star, every planet, every person, every thought that's ever been thought by any conscious creature anywhere in this cosmos, one extra particle per billion. By the time the universe is 3 minutes old, the temperature's dropped enough for protons and neutrons to start fusing. The same process that powers stars, but happening everywhere, all at once, across the entire universe simultaneously. In those 3 minutes, all the hydrogen and helium that has ever existed, roughly 98% of all the normal matter in the universe, was forged. 3 minutes. The universe spent 3 minutes writing the recipe for every star that would ever shine. Scientists didn't believe this at first. The math seemed too clean, too precise, almost suspiciously perfect. Then they ran the numbers against what we actually observe in the oldest light in the universe, and the match was exact. There's something quietly staggering about that. The universe is nearly 14 billion years old, but the raw materials for all of it, the hydrogen in the water you drink, the helium in the sun warming your face right now, were locked in during the time it takes to soft boil an egg. But wait, we haven't talked about what this would actually do to you. Imagine, just for a second, that you exist 1 second after the Big Bang. You don't, obviously. Atoms don't exist yet, which means you don't exist yet, which makes this a thought experiment that your own existence makes impossible. But stay with it. The temperature around you is 10 billion degrees. Not the kind of heat you feel near a fire or even near the surface of the sun. The sun's surface runs about 6,000 degrees. We're talking about a temperature 1,600,000 times hotter than that. Your body, if it could somehow exist, wouldn't vaporize. Vaporization is way too slow, too polite a word. The energy density would disassemble you at the subatomic level before the concept of you could even form. Every direction looks identical. No up, no down, no dark corner anywhere. The universe is smaller than our solar system, and every cubic centimeter of it is a furnace beyond anything we've ever imagined. The pressure pushing on you from every direction would be immeasurable. Not because we haven't tried, but because any instrument we'd build to measure it would be made of matter. And matter doesn't exist yet in any stable form. You look around, nothing. Absolutely nothing. Not because it's dark, but because light can't travel. The plasma is so dense that photons are immediately absorbed and re-emitted, trapped in a fog of pure energy. The universe at this moment is opaque. Totally, completely, utterly opaque. It'll stay that way for the next 380,000 years. And here's what nobody really talks about. That moment, 380,000 years after the bang, when the universe finally cooled enough for electrons to latch onto protons and form stable atoms, and the fog lifted. That was the first moment in history that a photon could actually travel freely through space. The flash from that moment is still out there right now. We call it the cosmic microwave background. It's surrounding Earth from every direction. It's been measured, it's been mapped. And if you tune an old analog television between channels, that faint static you see, about 1% of it is actual photons left over from that moment, hitting your screen after traveling for nearly 14 billion years. The oldest light in the universe, in your living room, after the fireball, after the plasma, after 380,000 years of opaque, featureless fog, the universe went dark, completely dark. No stars yet. Gravity was slowly, patiently pulling hydrogen and helium together into clouds. Those clouds were collapsing under their own weight. The cores were heating up. But it takes time, a lot of it. For somewhere between 100 and 200 million years, the universe was just dark and silent. Astronomers call it the cosmic dark ages. And then one by one, the first stars switched on. They were enormous, hundreds of times more massive than our sun. They burned hot and fast and died in supernova explosions that seeded the universe with heavier elements: carbon, oxygen, iron, gold. The building blocks of chemistry, the building blocks of life. Every atom of carbon in your body was forged inside a star that died before our solar system even existed. And honestly, You are not made of stardust in some poetic, metaphorical sense. You are literally the recycled nuclear ash of stars that burned and exploded billions of years before Earth was a thing. The Big Bang didn't just create the universe, it created the conditions for you. Specifically, inevitably, in a chain of events so precisely dialed in that if the ratio of matter to antimatter had been even slightly off, if inflation had lasted a fraction longer or shorter, if the fundamental forces had been tuned just a little differently, none of this exists. No chemistry, no planets, no life. The universe had one shot to get it right. Here's the thing that no textbook quite prepares you for. The Big Bang wasn't something that happened out there, somewhere distant in some other place. It happened here. The point it exploded from, that singularity, isn't a location in space. Every point in space is that location. The center of the Big Bang is wherever you're standing right now. You're not the descendant of the Big Bang. You are the Big Bang, still expanding, still carrying the momentum of that first incomprehensible instant, still unfolding. When you look up at a clear night sky and see the light of a distant star, you're seeing photons that left their source thousands or millions of years ago, traveling across an expanding universe, passing through the remnants of ancient supernovae, threading through galactic dust, and landing finally on the retinas of a creature made entirely of the same stuff as that star. The universe looking at itself. That's not poetry, that's physics. Tension, final, slow build. And here's the last thing. The thing I've been holding back, the observable universe, everything we can see, everything we can measure, the 46 billion light-year bubble of space we call home, isn't the whole universe. It's just the part where light has had time to reach us. The actual universe could be infinite, not very large, infinite. Which means the Big Bang didn't just create a universe, it may have created an infinite one. And if it's infinite, if it genuinely goes on without end in every direction, then by pure mathematics, every possible arrangement of matter that can exist does exist. Somewhere, infinitely far from here, every variation of this exact moment is playing out right now. We started from nothing. We became everything. And we still don't know why. If that left you unsettled, if you're sitting with a question you can't quite name, subscribe. There's more where that came from. The universe has barely started talking. The Big Bang. What actually happened in the first 3 minutes. The Big Bang wasn't an explosion in space. It was an explosion of space. And what happened in the first 3 minutes after it changed everything that has ever existed. This video breaks down the